Hi, I'm Eric Koeritz. I'm a PhD candidate in the turfgrass breeding program here at the University of Minnesota. And today I'm going to be talking about some of the impacts of rust pathogens on perennial ryegrass in Minnesota. So perennial ryegrass, the turf we're standing on here, is an important turfgrass species used around the world as a component of lawn turf mixtures, as a high quality athletic field. And it's also used a lot for overseeding dormant warm season grasses in the southern part of the United States. What a lot of people don't realize is that northern Minnesota is actually a major seed production area for perennial ryegrass. Perennial ryegrass seed production industry, along with its associated seed processing and distribution businesses, are worth between $15 and $20 million annually. Some of the challenges that this industry faces are rust pathogens in both the seed production fields and in turfgrass situations. In a turfgrass situation, crown rust is the rust pathogen that's most problematic, and in a seed production situation, stem rust is the rust pathogen that's most problematic. Now, both of these rust pathogens are spread via asexual spores called uridinospores. These uridinospores are dispersed via wind currents, and when these spores land on a wet leaf surface, they germinate, produce a germ tube, and this germ tube grows across the leaf surface until it encounters a stomata, where it grows inside the stomata, and once established, it extracts nutrients from the plant. And in a turfgrass situation, this causes mostly cosmetic issues. Stem rust in seed production fields, however, is a bit of a different issue. It's not just a cosmetic issue. Stem rust infects the stems versus mainly the leaf tissue, and when stem rust infects these stems, it limits nutrient flow from the leaves up to the seed head where the seed is produced, thus leading to lower seed yields, reduced seed weight, and reduced seed quality. So there are several ways to control rust pathogens in both a turf and seed production situation. The main way is to maintain healthy plants. In a turf situation, this is usually done by maintaining adequate irrigation, adequate fertilizer, and just keeping the plant actively growing. In a seed production situation, you also want to maintain a good, healthy, robust plant, but in addition to maintaining adequate moisture and nitrogen, we also use things like plant growth regulators to keep the plants shorter, more stout. So another way to control rust pathogens in perennial ryegrass is by the use of fungicides. However, it's not usually economically viable in a turfgrass situation, and in a seed production situation, it's also costly at up to $125 an acre, but it's also not considered an environmentally sustainable approach to controlling rust pathogens. So one of the most viable long-term solutions to the issues we have with rust pathogens is to incorporate genetic resistance into our perennial ryegrass germplasm. And the traditional approach is to do a phenotypic evaluation or screening in the field, where we depend on natural inoculum to infect our germplasm sources. We need to develop a new method for selecting for rust resistance that's not dependent on the time-consuming and highly variable phenotypic screening. So my project, which is trying to develop a novel approach for screening for rust resistance, try and get a profile of these chemical compounds within the plant and correlate these chemical compounds with the level of disease resistance in the plant, and then use the chemical compounds which are associated with disease resistance as biomarkers for selecting for resistance in our germplasm. So what this approach will allow us to do is select rust-resistant germplasm much faster and hopefully more accurately. And as we get more of a biological understanding of what chemical compounds are the plants producing that are used as plant protectants, the ultimate goal of my project is to develop new perennial ryegrass varieties that not only have excellent stem rust and crown rust resistance, but also have excellent turf quality, good seed production characteristics, and are very hardy under the Minnesota environment.